In this chapter, we're going to introduce the list data structure. A list is a way to store multiple data values under a single name. And like I like to do, let's start out with a motivating example to describe or explain why we need lists. So let's say I want to keep track of some grades in a class so that I can compute the average. Or for whatever reason, I just want to keep track of grades. Well, without a data structure to do so, I have to keep a variable for each grade. So for this example, I'm going to keep the data set size small and only show 3, but in a typical class, there might be 20, 30, 40 students. So you can imagine 40 variables. Well, here I have 3 variables. Then I have to assign scores to those grades. So I do that for each variable, and that's really the easy part. So if I want to compute the average, the first thing I'm going to have to do is create a variable called sum and individually add the grades to the sum. And again, imagine that there's 20 or 30 grades and not just 3. Then I compute the average, and then we can display the average. So let's run that program. So the average is 86. Now, that's not too bad, but again, we're working with a very small data set. With a lot of data, this would have been a very hard program to write. Now let's look at how we do it with a list. I'm going to demonstrate some of the features of a list without describing them in too much detail now. We'll get to that in the rest of the chapter. So the first thing I want to do is create the list. So I do that with the keyword list. That's the name of the data type. Then we have to tell it the type of data we want to store in the list. In this case, it's going to be integer values, so I have to put int in what I call angle brackets, greater than and less than sign. Then I provide the name of the list. Then I call the constructor with empty parentheses like so. And that's what you have to do to create a list object. Then, when I want to add items to it, I simply call the add method with the data that I want. I don't have to worry about the size. The compiler automatically adds items for me when I need them. Now, if I want to compute the average, I can do it very simply. Double average is equal to grades.sum, which will add the grades for me, divided by grades.count, which will tell me how many grades are in the list. And then we just display the average. 86. One of the best features of a data structure like a list are these methods, sum and count, which can save me a whole lot of work. Without having the sum method, I would have to write a loop to loop through all the grades in the list. Without count, I'd have to loop through the list of grades and create a counter variable to keep track of how many grades are actually in the list. But now I can do the sum and the count with one method call. There are a lot more to lists than just what I've shown you here, but this is a good introduction to how lists work in C#. And in the following lessons, we're going to learn a lot more in depth about lists. So let's move on to the next lesson where we're going to talk about how to initialize lists.